So, hi again, everyone. We will talk in this presentation about the small personal fun project of mine. So as you see, even though I work for Cisco, the template is not really something related to that, because as I said, it's a fun project. No warranties, nothing official, but it's kind of a fun hack that I thought to share with you. And we'll talk about kind of four things. So I'll talk about the background for this. How did this all arise, and a little bit get you some insights into, well, some of my activities. And then I'll talk about hardware side, then the firmware side, and then hopefully if all works well and the presentation gods are with us, and there will be some live demo as well. So the background, and the background of all of this gets into event networks, so large-ish events, so to say. So I'm lucky to have been part of the network operations team for an event called Cisco Live. So if you are in computer networking, and if you are, well, regardless of whether you're US and Europe, you know about Cisco Live, and Cisco Live Europe is something that has been very close to my heart. So I've been part of the NOC team for the past more than 15 years, I'd say. And it's very fascinating. It's all the time you see this, how in less than a week, the things transform. So you see these big event halls that transform from this really construction site into something very glitzy and glamorous. And of course, none of this can happen without the connectivity, right? And that's the part where the team I work with kicks in. So that's a lot of gear. And in these pictures, you see more than 500 Cisco compact switches that form kind of the access layer of the network. And they're being provisioned. So normally they're being pre-provisioned beforehand. Then we pack them in the pack them in the flight boxes, and you see that even though this switches, they're not very new model, but they're still there, and they fit very, very nicely into the flight cases. And on the right picture, you see there's a lot of flight cases to come in, so that flies into the events. And kind of course, preparing all of the switches, it's kind of a difficult task. So over time, it all started with classic old times, with a lot of people sitting a couple of months before the event, sitting there with the console cables, with copy pasting the configs into them. And kind of gradually also the networks grew, and eventually we kind of decided, hey, how about we stop copy pasting and we do some, well, a little bit automation. And about 10 years ago, we started a little in-house project that was, at first it was just changing the addresses, because all of the other configuration was the same. And then it kind of grew, and it grew, and it grew, and eventually now it is a pretty, since probably 5 years ago, blown network management system. And it was C# at first, so that was another person running it. Then I inherited it, and then in 2017 it was a very good excuse to learn Rust, so I rewrote it in Rust. But well, that's not really a topic of the presentation. It's kind of a little bit of an add to automation in general, because automation is a good thing. And also, well, from this project, from the rewrite, on my GitHub, you can find some spare parts from it that I could extract and automate. So it's TACAX library, some Postgres to SQLite migration tools, some web framework, and experimental, and so on and so forth. But the key thing with having these automation systems is that we went from having 20 engineers for 2 weeks to kind of having 1 or 2 happy guys locally doing all of the job of pre-provisioning, pre-configuring switches before they get shipped on site, doing it pretty much in 1 day. And well, they also were doing it part-time. So they basically would connect switches, let the job finish, and continue. And also this automation allows us to do a lot of last minute changes. And also the nature of all the events, if you ever were into the event networking, you would know that there's constantly a lot of changes. It's a very nice kind of hacker ground in a sense that you have in the, well, as Peter said, in the old sense of this word, in that you have to do a lot of last minute decisions, last minute changes, be creative. Let's say, well, we had a situation where one of the switches was installed too early, and then it was driven over by a cherry picker. So it kind of didn't work very well after that, but it physically survived, but we have it somewhere in our, well, museum. So this solution kind of, everything today has to scale horizontally, right? So this, as you see on the picture, it scales very well horizontally. The reason for this horizontal scaling is not the capacity, but the thermal profile of the compact switches, because they get by themselves relatively hot, and it's nice to have the airflow through them. So, but, well, especially when it's hot, when we just start the preparation, when the air ecosystems are not yet in full speed, because that's a lot of gear that we're preparing. So, but it also scales very well vertically, as we discovered. So for it was a couple of years ago, we changed the topology slightly, so it became very, very layer 3 centric network. It was 50 layer 3 switches, and to serve that capacity, we got well 50 Catalyst 9300 switches, which are running as layer 3. And as we were provisioning them, so there's this NMS thing that we adopted. It worked with them as well. As we were provisioning them, well, we kind of saw the light in that, being newer generation of equipment, they have this ID light with buttons on both sides, and both sides have the lights. And this is super handy if you have the boxes installed, if you have the devices installed in racks. So you press the button, the light goes on, and then, well, either you yank the power from the correct switch, which is kind of handy, or you're plugging the ports into the correct switch as well. So this was something really, really nice we found out. Because, for example, you can see that the switches are labeled. So that labels are also part of kind of this whole network management system. So every new switch that comes into the kind of system is inventorized, and we assign this S and 4 digits number. And then there is also the MAC address of the switch that is printed, and it's all barcodes. So we can very, very trivially check in, check out, so we know where the switch is, how many switches we have dispatched at the deployment time, because as I said, the entire preparation takes about a week on site, but the installation of the network is usually completed within probably a day or two. So you can imagine the 500 switches get really flown out very, very fast. And the tear down of the network happens in about 6 to 7 hours. So again, that is kind of this big cow's time when you have a lot of stuff moving around. So that's where identification and labeling was super paramount. And yeah, so, and then ID lights, we found that they were software controllable. So we added support for that. And that tremendously eased the labeling process, because we had just this stack of switches that were unlabeled. And then what we could do is say, hey, I'm holding this label for switch S655, blink me the light on the switch that has this number. So software knows which switch is which, and then it would blink the light. And then you could just take the label and put the label on the switch. So this way, instead of spending a couple of days on labeling, or well, full day, it was done in under an hour for all the 50 switches. So that was very, very nice. Again, the benefits of automation, I can attest to that. So, and we have all this automation. So during the event, generally, if everything goes well, and the past few years, again, thanks to automation, it was very, very, very calm. So we kind of pondered, well, so we have 500 of these existing small, older access switches. So what can we do? That would be really cool to attach this light, to have this light there, right? But there's not really that many options. And we kind of were just thinking aloud as engineers do together, thinking, okay, so what kind of connection can we use to trigger something, to blink something, to turn something on when the switch is ready. So to blink a light that, okay, well, you can disconnect the switch during the provisioning, or you can signal that there is some kind of problem during the operation, and so on and so forth. So then kind of there is quite a few options there, but well, so there is two USB ports, so one USB type A, one mini type B, which we discarded right away because that is just the USB to serial converter that is attached there. Then there is console port, RS232, RG45, and then there is quite a lot of Ethernet ports. So, and then we kind of were sitting and discussing, so what options do we have, right? So first, USB type A, well, it is pretty cool because it is very easy, 5-volt source. And as we discovered, it was actually one of the reasons, if you ever were to several latest Cisco Live events, you noticed that there were charging stations that appeared at one point. So they appeared actually because at one point there were no charging stations, and then exhibitors or visitors would find these nice compact switches that were blinking lights and had a USB port. And people on to charge it, and well, sometimes it even works, sometimes the power draw was a bit too much, so then the switch would reboot. Well, then we would dispatch someone from the network operations. They would come and well, have a discussion that this USB port is not a charging port really. So from that standpoint, it was also nice to block this port, because anything inserted originally would probably prevent people from inserting something else, because generally folks don't unplug things. But yeah, so this had also cons, because USB is not a very trivial protocol. So it would need a driver. So the switches run iOS Classic, so that would need some kind of modifications. You would need to convince people of writing iOS that's having this kind of strange USB gadget would be useful. And then, well, it needs to be official, and so on and so forth. And even then, USB protocol is kind of complicated, right? So having 600 of those, it's well, given that we didn't really have any official project, it was more like the experiments fantasizing that wouldn't be feasible. So the verdict of going with that was negative. Now, the Ethernet ports. The Ethernet ports kind of seemed like, well, it's good because PoE is pretty well known. You can power practically anything on Earth with it, right? So there is PoE. Even I've seen the PoE to USB-C charging adapters. So it's kind of cool. It's a nice technology, and it's very well understood, works very well. But again, the cons are that the PoE protocol itself is fairly complicated, even on the hardware side. So beyond from some very, very basic thing. And also another thing is that, well, actually manipulating the light that would be powered from this port would be kind of tricky, because, well, let's say the switch reboots, so then obviously it loses the PoE on its ports. PoE needs to be configured. So it's kind of a lot of moving parts. And then, well, even if you configure the PoE, let's say if you want to do something else than on or off, then you need to teach that device that has the light to even understand the packets, and then you are into having the IP stack on it, and it's kind of, it becomes very, very unwieldy. So the result is that this is also not suitable. So really what we have left is the RS-232 port, right? So this one has immediately quite a few pros. It's a very trivial protocol to work with, right? So you have essentially the binary signal, start bit, stop bit, bits in between, you sample it with the given interval, then you get the value. It's very, very easy. Then again, anything inserted here would block the console port, which is a plus because we don't want people plugging in things into the console. And kind of even during the provisioning, we don't use the consoles that much because it's all automated. So that's cool. And also another thing that is kind of we had in the back of the minds during discussions is that RS-232 itself as a protocol has been made to operate at a fairly large distances. So probably even the circuitry inside the switch would be, well, a bit less susceptible to any problems should the problems arise. So it felt like a very interesting option, right? So the only kind of question was like, from, right? So there is, of course, there is RS-232, which is the signaling, right? So you have to have some kind of things changing electrically, but is that enough to get the power or not? Well, so kind of the verdict at the time was a little bit like this, that we had this discussion. It was fun. It was interesting, entertaining during the event. And then so it was parked. And the event was finished and we went home. So, but then came pandemic, and then I was sitting at home, of course, like many of us in lockdown. And this idea came to mind that it would be interesting to actually explore this a little bit further. So I started to read things a little bit and read a little bit more in detail about the serial protocol, what the options are. So looks like it seemed on the first glance that it was actually pretty feasible. So we have some range of voltages that change, and it looks like let's measure them. So that was a little RG45 cable that was the Ethernet cable in its past life, as you can see. And then I plugged it into the console port and put the multimeter to see what's on it. So the result, as you see, was pretty good, pretty nice. It's 545 volts, so not too high, not too little, pretty good. And as per protocol, the transmit the TXD pin on the console port was low, so the voltage was negative compared to the ground on the console port. And yeah, the funny tidbit is that it's actually a pretty cool layout of the signals, in that if you roll over, so if you change the pin numbering, so if you, instead of 1, 2, 3, 4, 5, 6, 7, 8, you go in the other direction, then instead of the data communications equipment, you get the data terminal equipment. So kind of connecting, making crossover cables is very easy. So they're just use the rollover. Anyway, this seemed fairly promising. So I sat down and tried to figure out what the schematic for this would be. And kind of the first idea was that it would be something like that. So this is kind of a fun project for just education experiment, right? So you can see that there is no circuitry to deal with the potential overvoltage, right? So if there is overvoltage, then the capacitor will probably die. But since the voltage was 5 plus a little bit volts, and that was kind of the target audience for this little experiment, then that seemed to be like an appropriate thing to do. So basically, the only thing that I've been working partial in security as well for some time, so having 100 ohms just for the sake of it, just to limit the current, just in case some things goes wrong, that seemed to be like a useful precaution. And yeah, so another kind of funny thing is that you can notice that I have the markings. So there is two different grounds, right? So there is the ground from the console cable, and there is the ground that goes to the rest of the circuitry for power harvesting. So in this case, the signal is negative by default. So that means that kind of the meaning of the ground and VCC, so the positive power supply voltage, is reversed. So that way, so the VCC, the RS232 ground, which is kind of not perfect, but it is what it is. So fine. So that way, the default state of the serial interface, so the TXD, is 0, so it's -5 volts. So we charge this capacitor C1, and with this capacitor, we can hopefully power some sort of circuitry for a while, right? So now, when we send the logical one, so when the port is active, when it's sending something, the polarity will change. So the voltage will change. However, there is a little bit of a trick here, in a sense that, so first the C1 charges to 5 volts, right, during the idle time. Then what happens is that the transmit data changes the polarity. So it becomes from logical 0, it becomes logical 1. So it becomes +5 volts. So it's cool because if we put the diode in the opposite direction, so where the question marks are, there will be a signal. The only trouble with that is that because in our schematic that doesn't exist yet on the right, we are using the ground as a reference. So the new ground, not the console cable ground. We will have the 10 volts of voltage, because remember, C1 is charged to 5 volts, and then the Con3 TXD, so the console signal, is +5 volts of the console ground. So that will be probably almost 10 volts when measured off the ground on the right side. So yeah, and most of the schematics, most of the components, whenever you put the input signal that is twice the power supply, then they generally don't survive it. Sometimes, well, probably there won't be any magic smoke, but it definitely wouldn't function correctly. So just add the voltage divider. So if the voltage is 10 volts, add 2 resistors in series, and together with the voltage drop on the diode and together with our 100 ohm resistor, we will actually get something that resembles the right signal, right? So it hopefully should be something along the VCC value, even though that it's actually 5 volts in reality compared to VCC. So that's kind of the biggest nature of the hack in this presentation, and that it's a little bit of a hardware hack in how do we get the signal from something that is ±5 volts into something that we get the power from, and we get the signal to deal with it. So the rest is kind of more of details. So what do we connect it to? I had fairly long history with playing with Atmel microcontrollers, and I decided to use again the ATtiny. They're really cool because it's essentially a computer in a box, right? So you get 5 IOs. You don't need any parts. You can have more parts. You can have the quartz and so on, but it does have the necessary circuitry by default to drive everything, which makes it really cool. And another part that is really nice is that it has both deep 8, so this picture that you see on the photo layout, and it has a smaller SOIC 8 and even smaller layouts, which are useful for making something that resembles real-world usable products. And again, another thing is that it's fairly cheap. So it is usually, even if you buy one, you can get them under €1. So that's how the prototype number 0 was born. And again, being engineers, we start from zeros. So this was really, really quick hack. You see that there is 2 80-tinies. I just took the breadboard that I had with a couple of them. I didn't even remove it. It was a really quick thing to decode serial data from this hardware circuitry, then see what's there, and recognize some predefined string. If it sees the predefined string being sent on the serial, then it toggles the LED. So that was really the proof of concept. And well, yeah, it worked. So you see also that on the right side, I have a very interesting I already crimped in the 100 ohm resistor, but I kind of short circuited it. So in any case, it worked. So kind of the full schematic for the hardware looks like this. So it's 3 parts, and left side, it's the hack that we've just discussed. The right side is really nothing very interesting. So it is just the RGB light emitting diode and the microcontroller. And that's really that there is to it. So, and then, well, the prototype 1 was kind of, it was pretty antique form factor, just, again, because I had whatever components I had at the time. And it really was a while since I was playing with hardware before starting this fun project. So that's what I had. And yeah, I got the PCBs from oshpark.com. And if you're doing the PCBs, always use Express Post, because in Express, the circuit boards arrived in about less than a week. By regular post, they took about a month and a half to arrive. So that was quite a while. So that's the kind of useful information that I got from there. But also this form factor obviously was not something very suitable for production and, well, any sort of mass scale work, right? Because that meant a lot of soldering. While it's a very nice activity, but that's on the second 100, probably it will get fairly boring. So one of my friends told me about the GLC PCB company that they do both the printed circuit boards development, and also they do the component mounting, which was kind of cool. So, and also I discovered that they have a web-based circuit board and PCB layout editor, which was also very, very nice and easy for me, having not had done much hardware stuff at that point in time. So, and that's, the couple of pictures of prototypes that developed further. So the kind of R, G, and B LEDs separately on the right with the surface mount microcontroller. Then you can see the C1 capacitor for the power harvesting, voltage divider, and so on. So it's really a simple schematic. On the left, that was probably the smallest prototype that I made, because kind of even the form factor on the right, it looks fine. It's already better than the previous one, but it's still not very nicely deployable. So I had this idea that, oh, well, how about I try to fit it into the RG45 jack, into the RG4, and that would make it that would solve a lot of problems, a lot of questions. But the so the thing with this prototype, it was really small, really nice, but I kind of missed the part about connecting to RG45, because usually we don't think about these details. But you can see on the left side, so there are 2 pads to connect to the 3rd and 5th contact. They're too small, and it was really hard to do anything useful that would not fall out immediately. So kind of as a prototype, it was fine, but it didn't work really well. So the final prototype was having 2 small circuit boards. One that would be carrying all the components, and the other that would be thinner, and both would have two contacts. And then the assembly was, at least in the initial project and the initial idea, was that I would just insert this smaller board into the RG45. I insert the bigger board, then I'll crimp it in, everything will be fine. It kind of worked almost like that, because the two large pads have fairly nice contact. It's all fairly straightforward. The only problem is that it doesn't lock itself in. So the bigger board would always fall out. So, well, again, a little bit of a hack. So because I was doing a lot of work with RG45 by then, and I had a lot of cables. And then, yeah, you can see that on the left picture, yeah, that's the kind of reinforced prototypes with the folded coating, just keeping the second PCB in place and nicely, snugly contacted. So that's kind of as far as I went with hardware. It's, yeah, it's not perfect, but it kind of worked reasonably well.